Good evening. Welcome to
Math for Kids number 105.
Math for Kids number 105. Got kind of a tired kid here tonight, so let's pep up. Ready? Pep. I'm stuck. Pep, pep, pep. Pep up.
Nah.
Okay. Here we go. We're going to talk about base
4.
Base 4. So you said you want to talk about base 4. So base 4 is kind of like base 2 or a binary. Where in binary we only use zeros and ones. And we talked about base 16, right, where we used powers of 16, and we had numbers like 1A3.
Or dad.
Or numbers like dad. Base 16. So today we're going to learn about base 4, which is very similar, and I'm going to show you a really neat way to convert between base 2 and base 4 and base 16. I'm going to switch and sit on the chair here because yoga ball's giving me trouble tonight. Okay, so let's take a look at a number in base 4 that's like 3, 1, 2, 1. Base 4. Okay. So this is the 1's digit. This is the 4's digit, this is the 16's digit, and this is the 64's digit. How did I figure that out?
Powers of 4.
Powers of 4. 4 to the 0, 4 to the 1, 4 to the 2, 4 to the 3. Okay, so this number is 3 times 64 plus 1 times 16 plus 2 times 4 plus 1 times 1, right?
Yep.
Okay, what is 3 times 64?
See, it's 180. It's 192.
Okay, it's 192.
And 16.
Plus 16.
Plus 8.
Plus 8.
Plus 1.
Plus 1, which is?
Which is 217.
217, okay. So we just made up this number, 3121 base 4, which happens to equal 217. Base 10. I'm going to write that up there. Okay. So there's nothing really all that surprising about that, right? But now I want to show you a neat way to convert to binary.
To convert to hexadecimal.
And to convert to hexadecimal. Let's convert to hexadecimal first. Okay. Ready?
Yeah.
Okay, so this is actually pretty interesting. Let's look at the largest number we could make with these first two.
We can make 3.
The largest number would be what?
Would be 3. 2 plus 1.
3, base 4. That would be 3 times 4 plus 3 times 1. And what is that?
That's 12 plus 3, which is 15.
It's 15. Okay. Does that remind you of anything in hexadecimal?
Not really.
It's the largest individual digit in hexadecimal. Remember hexadecimal went A, B, C, D, E, F? This was 10, 11, 12, 13, 14, 15. So that's interesting. So the largest number we can make out of here, something times 1 plus something times 4, where we limit our numbers to 0, 1, 2, 3, the largest number we can make is 15. So what you're going to do is the first digit in hexadecimal goes up to 15. And the first 2 digits in base 4 also can go up to 15, so we can just make them the same by whatever this number is in base 4. We just use that in hexadecimal.
Yep.
And you're going to fall asleep on me? Okay, so what's 2 times 4 plus 1?
It's 9.
9. Okay, so if we're going to convert this number, we're going to use a 9 base 16 for the first digit. We're going to do the same thing with the second digit. We're going to use the next 2 for the second digit. Okay? Now this is a little confusing because we're talking about 64s and 16s. But remember, this is the same as 16 times 4 and 1, right?
Yep.
Just like the first 2 digits. So out pops a 16. Very interesting.
16 is in hexadecimal.
Very interesting. So we do the same thing here. So we do 3 times 4 plus 1 times 1, which is?
Which is 12 plus 1, which is 13.
Okay, 13, and 13 is D. So we think this number, we group it in groups of 2. So we think this number, 3121 base 4, is the same as D9 base 16. Okay, let's see. This is the 1's digit and the 16's digit. So we have 13 times 16. That's D, right?
Yep.
What is this?
13 times 16?
Yeah, what is 13 times 16?
It's 208.
Well, let's see. It's 130 plus 60 plus 18, which is exactly
208.
208 plus 9. And what is 208? Well, sorry. D times 16 gives us the 208. Then we have to add in the 9.
1 times 9 is 9, so that's going to be 217.
217, which is exactly what this number was. Isn't that interesting? So there's a really easy way to convert between base 4 and base 16. You just group in groups of 2 and then convert the numbers.
Now how about in binary?
Ooh, now how do we convert to binary? We have to do the exact opposite. Now, powers of 4 remind you of powers of 2, right?
Yeah.
Definitely. Okay? So now, instead of grouping in groups of 2, 3, 1, 2, 1, base 4, we're going to expand. Okay? How do we make a 1 in binary?
In a 1 in any place.
How do you make a 1 in binary? What gives you a 1?
Well,
a 1 in binary is just a
1.
I wasn't trying to trick you. 1, to make 1, you just need a
1.
Okay, we're going to take each one of these digits and expand it into 2 digits. Okay? So a 1 in binary is 0, 1. Okay? A 2 in binary, how do you make a 2 in binary?
It's 1, 1.
1, 1?
No, it's 1, 0.
1, 0. How do you make a 1 in binary?
It's just 0, 1.
0, 1. How do you make a 3 in binary?
That's 1, 1.
That's 1, 1. So watch what happens when I write this number out. 1, 1, 0, 1, 1, 0, 0, 1. 1, 1, 0, 1, 1, 0, 0, 1. Just make sure I got it right. I'm going to group it in groups of 2. 1, 1, 0, 1, 1, 0, 0, 1. Okay, looks like I got it right. Okay? And this is in base 2. This is the 1's digit, the 2's digit, the 4's digit, the 8, the 16, the 32, the 64, and the 128. Right?
Yeah.
So this number is 128 plus 64 plus 16 plus 8 plus 1. Let's see what that is. That's 100. 20 plus 60 plus 10 is
90.
Now we go 8 plus 4 is
12.
Plus 6
is 18.
Plus 8
is 26.
Plus 1 is
27.
So 100 plus 90 plus 27 is
217.
217.
Good.
Okay. So when you have similar powers in your bases, you can actually convert between the bases really easily. Now, I went through this super fast. I was just trying to show you that this is kind of a neat thing to do. But we always got 217. Pretty amazing, huh?
Yeah, pretty amazing.
Now, base 4 is not something that anyone really uses all that much. People use base 2 a lot, and they use base 16 a lot. But it's fun to see how to do things in base 4. It's just that people don't use base 4 very often.
Yeah.
So, is that fun?
Yeah.
All right. So that was our last video for this week. So next week we'll go back to doing some, some mom's problems or something. All right.
Yeah.
All right. Good job.